Technically speaking, I ain't talking vegan when I said that I've been eating, making money on the side, but I use it for the main.
If your healthcare organization is running workloads on AWS and someone on your team has administrator access, then this video is for you. My name is Jessica, and I'm the co-founder of Technically Speaking, a cybersecurity and GRC compliance firm based in Houston, Texas. We work specifically with healthcare organizations on AWS and Azure environments where HIPAA compliance is the baseline, not the goal. In this video, I'm going to walk you through AWS IAM Hardening for HIPAA compliance, step by step. This is actually in the AWS console, as you can see. So we're going to cover three things here. First, what HIPAA section 164.312A1 actually requires of your IAM configuration, not the legal language, but just what it means in practice, okay? And then second, we're going to talk about the three most common IAM mistakes I see in healthcare AWS environments. And all three of these are fixable in one afternoon, right? And then third, a live walkthrough of the exact checks I run when I assess new clients and their IAM environment, all right? So let's get on. So let's start with the regulation itself, because most people have either never read it or only read the legal language of it, and they can't really translate it into action. So HIPAA Technical Safeguards, section 164.312A1 says, and I'm paraphrasing here, that covered entities must implement technical policies and procedures for electronic information systems that maintain PHI to allow access only to those persons or software programs that have been granted access rights. So break that down, and it means three things in your AWS environment. One, not everyone should be able to access everything. Let me pull up my GitHub here so you can actually see, right? So one, again, not everyone should have access to everything. Access must be intentional and role-based, okay? Two, who has access to what must be documented. You can't claim compliance if you can't show an auditor a clear picture of your access model. And then three, access must be reviewed and maintained. It's not a one-time setup. People join, people leave, and roles change. Now, here's why this matters specifically in AWS. Okay. Now, AWS Identity and Access Management, IAM, is the control plane for everything in your account. S3 buckets with patient data, EC2 instances running your application, or RDS databases storing ePHI. Every single one of those resources, they're gated by IAM permissions. So if IAM is misconfigured, everything downstream is exposed. And that's regardless of how well you set up your encryption or set up your logging. IAM is not one safeguard among many. Okay, it's the foundation everything else sits on. Now, I want to walk you through the three mistakes I see in almost every healthcare AWS environment I assess. Not sometimes, but almost every time. Mistake one, everyone is an administrator. I've walked into environments where 10, 12, 15 IAM users all have administrator access. When I ask why, the answer is almost always the same. It's easier basically to give everyone admin than to figure out what each person actually needed. And here's the problem with that. HIPAA requires that access be limited to a minimum necessary. And an analyst who only needs, to read from an S3 bucket should never have the ability to delete an EC2 instance or maybe even just modify your CloudTrail configuration. Administrator access means that they can do those things. And in a breach scenario, if one admin credentials, let's say they're compromised, the attacker has full access to your entire AWS account, every resource, every piece of ePHI, and there are no guardrails, right? Mistake two, policies attached directly to users. In AWS, there are two ways to give a person permissions. You can attach a policy directly to their IAM user account, or you can create a role, attach the policy to the role, and assign the user to that role. The first way, direct attachment, creates a management nightmare. When you need to update permissions for a job function, you have to find every user with that function and update them individually. When someone leaves and you're revoking access, you have to find and remove every policy manually. There's no real clean audit trail of what role this person was or supposed to have, nothing like that. Now, the second way, role-based access, right? Role-based access. This is how IAM is actually designed to work. You define roles that match your actual team structure, like data analyst, operations engineer, administrator, right? And you attach policies to those roles. And then the people, they inherit permissions from their roles. And that's really clean, that's auditable, and it's maintainable, right? Let's talk about mistake 3. No IAM governance process. This one doesn't really show up in the AWS console, but it does show up in conversation. I ask every client, if I joined your team today, how would I get AWS access? And if I left tomorrow, how would you make sure my access is gone? Most of the time, the answer to both questions is someone just do it. No written procedure, no checklist, no timeline for when access gets revoked, which means there's a decent chance that former employees, former contractors, or even former vendors still have active credentials in the environment. Okay? A governance process isn't complicated. It's a document that answers 4 questions. How is access granted? How was access revoked? Who reviews access quarterly? And how do you handle emergency access? That's it. All right, so let's actually get into this AWS console. I'm going to walk you through exactly what I look at when I do an initial IAM audit. So the first stop is the users list. Okay, as you can see, we have users IAM. You can click here, look IAM or search IAM. It's really up to you. And then you want to go into users. And this is the list of users. We have 10 users here. The first thing I look at is how many users are here and what do the names look like. Right away, I'm watching for red flags here. Are any of the users named admin, share, team, test? Those are almost always shared credentials, basically with multiple people using the same login. That is a direct violation of the unique user identification requirement. Are there users that look like they might be old? Check the password last used and access last keys used columns. If someone hasn't logged in for 90 days, their account should be reviewed and potentially disabled. Now, we're going to click into a user here. Let's go to Analyst 01. Now, 2 things I'm looking here is first, an MFA device. Let's go to Security Credentials, MFA. First, MFA device. Is there an MFA device registered? If the user has console access and there's nothing in the MFA section, that's a fail. No MFA on a user with console access is one of the highest risk gaps I see. Second is access keys. Let's go into here and let's click on our access keys, right? We got access keys. If there are access keys here, which, you see, when were they created? When were they last used? Any key that's never been used should be deleted. Any key older than 90 days that's still active should be rotated. Root account access keys, if they exist at all, should be deleted immediately. No exceptions. Okay, let's come into here and let's look at the permissions policies here. Now, under permissions, you're looking for 2 things. The permissions policy section will show you any policies attached directly to the user. In a well-governed environment, this section should be pretty empty. All permissions should flow through groups or roles, not direct attachment. All right. The second thing, if you see administrator access anywhere, whether it's directly attached or inherited through a group, make a note of that. You want to know exactly how many accounts in the environment have unrestricted access. So basically, I would just run through every user this way. It takes maybe 20 minutes for a small environment like this, and you're just building up a mental map of who has what and who shouldn't. Okay. Now, let's look at policies directly. So we have IAM, and over here we have policies. We're going to go ahead and click on that. And as you can see, it brings up the policies. Now we're going to filter by type, and the type is going to be customer manage. Okay, these are policies your team wrote as opposed to AWS managed policies. Now we're going to click onto this policy, and we're going to go into the JSON tab. Okay, so let's click on JSON so we can actually see this policy in detail. Okay, this is where you see what the policy, the permissions and what it all grants. Now, what I'm looking for are wildcards. Specifically, I'm looking for lines that look for things like this, right? A wildcard. It may say action with a wildcard or resource with a wildcard, right? And as you can see, we have resource with the wildcard. A wildcard in the action field means that this policy grants permission to do anything: read, write, delete, modify, or whatever resource the policy targets. A wildcard in the resource field means this policy applies to every resource in your account. Okay? Both wildcards together, which you'll see in the administrative access, means that this user can do anything to anything. And that is the opposite of least privilege, right? Let me show you one that has anything. Let's do administrator access, okay? Just so I can show you. As you can see, action and resource. Again, these two together mean that they can do anything and everything, and we don't want that. We don't want that. We want them to have least privilege, okay? So a well scope policy looks different than this. Let's go back into policies. Let's go back into customer manage. We want our analyst read policy. We've created this, right? We want them to only be able to, their action is very specific, okay? You'll see the specific S3 get object version. You can see S3 get, a lot of get. You can get the object, get the bucket policies, right? These are the specific things you can do. You cannot do everything, right? We don't want wildcards, okay? Now, you'll see all these specific things, and this is exactly what you need to see instead of the stars. If you're seeing wildcards in custom policies that non-admin roles are using, that's a remediation item, okay? The fix is to replace the wildcard with specific actions that role actually needs, all right? Now, while we're here, let's go ahead and look at roles. So we're over here on the plane. Let's go to roles. And roles in AWS serve two purposes. One, they're how you assign job function-based access to your human users. And two, they're how AWS resources access other AWS services, such as like an EC2 instance that needs to read from S3 should use an IAM role, not hard-coded access keys, okay? So if you click into a role and look at the trust policy, let's look into a role and look at our trust policies here, trusted relationships. This tells you who or what can assume this role. For a human user role, you want to see your AWS account number and specific IAM users or groups. You don't want to see a wildcard principal. All right, as you can see, no wildcard. Then I want you to look at the permissions tabs. Okay, the same rules apply. Specific action, specific resource, and no unnecessary wildcards. Okay. Now, the last thing I do want to show you is the MFA enforcement. This is the single highest impact control you can implement today. Now, in the IAM console, where we're at here, we're going to go to the credential report under access reports. So as you can see, credential reports. And what we're going to do is download the report and open it in Excel or maybe Google Sheets. So let's go ahead and download that. And we're going to open the file. Okay. Let's just exit out of here. Now, I like to look at the user, right? And we're going to find a column called MFA active, which we see here. All right. And every row where this column shows false for a user who has console access, that's a gap. And we're going to write down each name. And as you can see, every single user in this environment does not have MFA active, which that is a gap. We need to write that down and let the client know that, hey, you need to add the MFA devices to these accounts, or at least the ones that have console access. Okay. Now, identifying the gap is step 1, and then enforcing MFA is step 2. And the way we enforce MFA in AWS is with an IAM policy that denies all actions unless MFA is present on the session. Now, AWS has a documented policy for this. It's called MFA Enforcement Policy, and I'll link it in the description so you can have that. Now, the policy works like this. It has a condition that checks whether the session was authenticated with MFA. If MFA is not present, the policy denies everything except the actions needed to set up MFA in the first place. So a user who hasn't set up MFA yet can log in and set it up, but they can't do anything else until they do that step. Now, you can attach this policy to a group and add all your IAM users to that group. And now MFA is enforced for every user in the account. The root account is separate. User is a little different. Okay, it's separate. You will click on the root. Is separate. So let's say you would click on the root and you would actually go into the security credentials and you would enable MFA and do it directly. Okay, you wouldn't put it in a group. Now, if you're walking someone, Now, if you're walking someone through enabling MFA for the first time, or let's say you're doing it yourself, the flow is IAM users, right? Select each user, whichever user, we're already in a user. We have our security credentials tab, right? And we're going to click on assign MFA, assign MFA device. And you can you can use a virtual authenticator app, however you want to use it. I like to use Google Authenticator or Authy sometimes. And then you would click device. Let's just say it's iPhone. Just putting it here as a test so you can see how it's set up. And you would show the QR code, scan that QR code. You would enter those two codes to verify, and then you're done, right? And then from this moment on, every time like a user has to log into the AWS console, they'll be required to enter their MFA code. And with the enforcement policy in place, you can have programmatic access, and access keys also requires that MFA authentication session, right? All right, let's end it here. Everything I just walked through is documented in my GitHub repo, HIPAA Cloud Security AWS. The link is in the description and pinned in the comments. The IAM folder has the policy templates, the checklist, the governance runbook framework work that I use with my actual clients. If you ran through these checks on your own AWS account today, you now have a short list of things to fix. And here's how I would prioritize them. One, root account MFA. If it's not on, stop everything and turn it on right now. This is the highest risk gap in any AWS account. Two, identify every account with administrator access that basically they shouldn't have it. And I want you to remove it. Replace it with scoped roles. Three, I want you to enforce MFA on all console users using the policy I described. And then four, I want you to document your governance process. Even a one-page runbook is better than nothing at all, right? So if you work in healthcare IT and you want a professional assessment of your AWS environment against the HIPAA technical safeguards, that's exactly what we do here at Technically Speaking. And the link is in the description. If this was useful, subscribe. I'm publishing practical cloud security content specifically for healthcare organizations every couple of weeks. I'll see you in the next one.